In this dashboard demo, you can see that I have imported my departments and users, and you can also see how many files have been classified. These classifications are categorized by departments and servers. I can filter the data to view specific classified files in particular tables. For example, let's say I'm using KSA labels with some in Arabic and some in English. Now, I want to check how many files are classified as confidential. A graphical overlay will display this data, and I can enlarge the graph for a clearer view. Additionally, I can select a specific regulation. For instance, if I choose PDPL, Personal Data Protection Law, I can see how many files should be protected according to this regulation. Upon applying the filter, I can see that there are 190 files in the finance team, but only 25 of them are classified as confidential. I can dig even deeper into the data. By navigating to another dashboard and selecting PDPL again, I can see the total number of files that should be protected and where they are located. For example, 31 files are in the quality team, 1 in the marketing team, and 190 in the finance team. If I click on the finance team, I can view details such as the users who own these files, the machine name, the user ID, and the file count. Furthermore, I can check file details, including file names and associated emails. For instance, I can see that a specific file is a Word document and view its exact file path on my machine. This allows me to take protective actions, such as deleting the file or applying security measures like masking sensitive data. By default, the label-based DLP engines can integrate with existing metadata from solutions like Trellix, Semantic, ForcePoint, and others. The DLP engines automatically process metadata and can be configured to act accordingly. Now, regarding your question about training classification models on your own data, that can be done from this screen. For example, with KSA labels, you can create your own classification scheme without any limit on the number of classification labels, or categories. You can upload data to match your custom labels or the system's existing labels. Once the data is uploaded, I can return to the classification schema section and click Train. The system will train the model, and once it's complete, it will provide accuracy statistics. In this case, the accuracy is 97%. Based on the training data used. If the results meet expectations, the classifier is deployed and will start automatically classifying files whenever a new document is created or sent. Now let me show you an example. Here's a file I created before the demo, which should be protected according to PDPL as seen in the dashboard. If I right-click the file and check its metadata, I can navigate to the CYBRAL tab, where it indicates that the file is classified as restricted or confidential. It also detects that the file contains clinical reports and patient information. Now, I will attempt to misclassify the file by changing its classification to public instead of confidential. However, Guard will recognize that the information is protected and prevent this misclassification. The system enforces classification rules, allowing the user to select only restricted or confidential. Why is this restriction in place? Because the file contains sensitive information that must be protected according to multiple regulations, including GDPR, HEPA, and PDPL. Let's open the file and examine its content. As you can see, it contains personal details such as a national ID, addresses, hospital admission dates, doctor names, medical diagnoses, lab test results, treatments, medications, and more. Now I will attempt to copy this information into an email. I will delete my existing email content and paste the sensitive data into a new email. The subject line doesn't matter because the AI engine is smart enough to detect sensitive information within the body of the email. Before I hit send, I want to explain what will happen. Guard includes a masking feature that can be configured in 2 ways. 1, manual masking. The user is prompted to confirm masking before sending the email. 2, automatic masking. Sensitive data is masked automatically before the email is sent. In this case, I have chosen manual masking. Now, when I attempt to send the email, the AI engine analyzes the content, detects sensitive information, and correctly applies the classification as confidential patient information. It then prompts me to confirm whether I want to mask the sensitive data. If I click yes, the system will only mask the sensitive portions while leaving non-sensitive content visible. Now, let's check the Sent Items folder. As expected, the non-sensitive information remains unmasked while sensitive data, such as patient details, admission dates, and medical information, is automatically masked according to regulatory requirements. GUARD ensures that only the necessary data is protected, aligning with compliance regulations. That covers the core features in GUARD. If you have any questions, feel free to ask.